today we're learning about solving problems in trigonometry. So either using two-dimensional shapes, or which is what we did last year, or expanding onto three-dimensional shapes. So things like pyramids and bridges in the water, places where you can create triangles in 3 dimensions that help us solve problems. So remember, trigonometry always goes back to triangles. So first we need to develop this trig toolbox. So you can feel free to pause the video and copy this, okay? This is just all the information that we've learned that we can use. So if it's a right triangle, we have SOHCAHTOA and Pythagorean theorem. If it's not a right triangle, you have to make sure you label it properly. So like that little a is across from big A. We have the sine law, the cosine law, and then all these angle relationships so that they all sum to 180. In a Z pattern, these are equal. That's very useful. Okay, if you have a straight line, these two angles are supplementary. They add to 180. And in an isosceles triangle, these two angles will be equal. In an X, opposite angles are equal. And of course, the F pattern, the green angles are equal. And in a C pattern, green and red will add up to 180. So like I said, you can pause that and make sure you get that all down. You always want to start with a sketch. Always, always, always. You need to label your parallel lines, your angles, and keep revising it anytime you get a new piece of information. And that will help you see, what do I know, what can I find out using what I know from my trig toolbox. Okay, in right triangles, SOHCAHTOA is always easier, but if it's not, you can use sine or cosine law. Okay, so really this is the true essence of problem solving. I have a problem, I have a set of information that I've learned in class. How can I use that set of information to solve this problem? I certainly won't need to use everything, but there must be something I've learned that will help me solve this problem. So we'll start with a two-dimensional question. Creating a triangular planting garden. So you want 2 equal sides. This is key because it tells you it's an isosceles triangle. They contain an angle of 135. So that means that the 2 equal sides, that the angle between them is 135 degrees. That's what contain means. And the longest side is 5 meters. So I know that the 5 meters must be across from 135, since that will be the largest angle. The largest side is always across from the largest angle. So how long is the edging needed to surround the garden? So that means basically I need to solve for side length A and side length B. So I created this diagram, and it's important to use variables just so that you can discuss them and communicate what you're finding in your work. So you'll notice that A and B are equal because it is an isosceles triangle. They're 2 equal sides. So we need to find what those are. Okay, so we cannot at this point use sine law or cosine law because although we have one ratio of an angle to an opposite side, we do not have a second angle and we do not have a second side. So we have to think, well, they must have given me enough information to come up with that information. So I need these in order to use the sine law. So let's think about this. It's an isosceles triangle, so what does that mean? That means these 2 angles are equal. So if those 2 angles are equal, we can label them with the same thing. We'll say that this is little x and little x. Okay, and I know that 135 degrees plus 2x has to equal 180 degrees. Okay, so this plus this plus this has to equal 180. So since they're both just represented by x, this is the only variable in this equation, I can just solve for x. So my 2x is equal to 45 degrees. So that means this whole thing has to equal 180. When you take 135 out, there's 45 degrees left, and they has to be evenly split between these 2, since it is an isosceles triangle. So my x is 22.5 degrees. So I can update this now that these are each 22.5 degrees. Okay, so I need to know my side length A and my side length B. So I can use the sine law to do that now. So A over sine 22.5 degrees equals 5 over sine of 135 degrees. I go through, I solve that, and I get A is equal to 2.71 meters. So therefore, B is also equal to 2.71 meters. Okay, so how much edging is needed to surround the garden? Well, the whole perimeter will be 2 times 2.71 plus 5. So that gives me a grand total of 10.412 meters. So you can write a nice sentence, therefore 10.412 meters, or approximately 10.5 meters, will be used to edge the garden. So now how about the area of the garden? So here's the garden again with this 5. Now we've found that these are each 2.71. So the area of a garden, or of a triangle, is base times height divided by 2. So we know that the base is 5, but we don't know the height. Okay, the height, remember, that's always, it comes from the top down and hits at a right angle. So we need to find this height. Well, if you look at this as half a triangle, it creates a right triangle. That's useful because now we can use either SOHCAHTOA or the Pythagorean theorem. So if you look, you know that this is 22.5 degrees. Okay? So I want to know the height, which is the opposite of the known angle. And I'm given the hypotenuse. So if I want to know opposite and I know hypotenuse, that means I can use sine. So sine of 22.5 degrees equals the height over 2.71, the hypotenuse. So using my calculator, I can find that the height is 1.037 meters. So now I can sub that into my area formula. Oops. So my area, when I sub that in, is 2.59 meters squared. Okay, and you can write a nice little sentence about that. Make sure you include your units. Okay, so that's a two-dimensional question. The rest of our questions, many of the rest of our questions will be three-dimensional. So make sure you understand that one. We used a lot of different information there. We used the fact that all of the angles sum to 180 in a triangle. We also used the fact that an isosceles triangle has two equal angles. We used SOHCAHTOA, all kinds of things. All right, so here's a pyramid question. So the Great Pyramid has a square base with sides 232.6 long. Okay, so I drew this square pyramid. So don't draw a square on the bottom. I drew a rhombus, so like an angled square, because that just helps you be able to see it better. Then you just draw a point above and then attach that point to the four sides, okay? Now I don't like doing it with markers because it smudges like that. That's why I did it ahead of time, but it still does smudge, I apologize. So the sides are 232, so this is 232.6, okay, and all of these are the same size, okay? The distance from the top of the pyramid to each corner is 221.2, so that's like from here to the corner, this is 221.2, so that's this, and that is equal, these are all 222.2. Determine the angle that each face makes with the base. So here's a face. If you can imagine A, D, I didn't label this, but this base here, what's the angle that this face is making with the base of the triangle? Okay, so if you can imagine this height, I'm going to erase some of these because they actually just get in the way. So imagine I drop down something that represents the height of this pyramid, okay, a vertical, and I would stop it in the middle here. So this is the height of the pyramid, okay, and I put it here to this base, and then I can imagine this coming down here. This theta is the angle they're looking for. So here's the height of the pyramid, here's the length of a face, and then here's sort of the middle of the pyramid there. It's this angle theta that they're looking for. Each face makes with the base. So how can I figure this out? I need theta. Okay, so, what can I start doing? There's lots of ways to solve this problem, okay? And you could, I encourage you to play around with it for a little bit. Now, I know that this length here is half of this 232.6 because it's a square. So if I'm hitting this right in the center, then that means this, if I call this length little a, from here to here, that a is equal to 232.6 divided by 2, so it's equal to 116.3. Since the base is square, it's a square base. Okay, so I know the length of this, and I need this. So this is a right angle triangle. So either I need to find the height, or I need to find this length A to, I'll call this C, A to C, where it's hitting there. So I either need H, or I need the length of AC. Either one of those will give me enough information to use SOHCAHTOA with this right triangle. Okay? So I'm going to choose to find the length of AC using triangle ACD, okay? Or sorry, this, so A to C to D. So if you look at it from the side, okay, so now I'm just looking at this face, okay? Here is C, here's A, and here's D, and we'll call this, I don't know, F. So that would be F. So I'm taking this side of the pyramid and just looking at it flat. So I know that this is 221.2, and this is 221.2, and this is 232.6. So I can find AC by just dividing that into one right triangle. So now I'm going to divide that even further, where this is 221.2, and this is AC, and this is DC. How can we find DC? Well, it's just half of 232.6, which is 116.3, because this is an isosceles triangle, so it will cut that in half. So therefore, to find AC, I can just use the Pythagorean theorem. So AC squared is equal to 221.2 squared minus 116.3 squared. Okay, that's just using Pythagorean theorem. So I can rearrange and solve and find that AC is equal to 188.159. Okay, so now if I go back to this triangle, okay, or maybe get a different color. So this triangle, again, that goes from the top of the pyramid straight down to the hitting the center, across to the side, and then along the face. Well, now if I draw that separately, it often helps to draw it separately, this is the angle I'm trying to find. I know that this is 116.3, and I just found that AC is 188.159. So therefore, I know my adjacent and my hypotenuse, so I can use cos. So therefore, theta is equal to the inverse cos of this, so it's 51.8 degrees. So that's the solution. So you'll see that without drawing a diagram, this is pretty much an impossible question, okay? Because A, you won't even really understand what angle it is they're asking you for, and B, you won't understand where all the right triangles are. Now, there is another way to solve this. Just a second. Where you create another right triangle down here, in this little section down here. You can also use that. You can get a whole bunch of different information. So I encourage you to try different ways, but you'll get that theta is equal to almost 52 degrees. So So basically the moral of the story is you have to be creating a different series of triangles and be finding different pieces of information as you go until you have the information that you need. So the other key part of this is figuring out, well, if I just found out, this side length, then I would have the angle I need. So how do I find out that side length? You kind of have to be able to work backwards. What do I need? What do I need to know to get what do I need? What do I need to know those things? If you work backwards, you can find a path that will lead to solving the problem. Okay, now part B is to determine the size of the apex angle of a face of a pyramid. So an apex angle is at the top. So this is that side AED. Okay, it's just one face. So the apex angle is this one here. Okay, that's what it's looking for. So you know that ED is 232.6. And you know that each of these side lengths is 221.2.